Welcome in, everybody. Today we are looking at what I can really only describe as a masterclass in digital note-taking and, well, problem solving. We've got our hands on a deeply meticulous blog post.
Extremely meticulous.
Yeah, from March 4th, 2026. And the mission for this deep dive is to basically extract the hidden lessons inside of it. To bring you right into the room with us, the source material is a post from a website called keynmm.org.
Right?
And the title is Notes on Haskell Programming, Part 73. And then the subtitle is Simplifying Nested Ifs with Guarded Helper Function. Now, we are definitely going to get into the code today, but I want to be clear right up front. This is about so much more than just programming.
It really is. It's a window into a highly specific kind of analytical mind. He's writing about Haskell, which, for those who haven't tinkered with it, is this notoriously strict, purely functional programming language.
Very academic.
Highly academic. It's an environment where you really have to think deeply about logic. Because of that strictness, it forces you to confront the architecture of your own thoughts.
And the author goes by Eng. He describes himself as an old software plumber.
I love that.
I do too. I love the humility in that phrase, especially considering the sheer intellectual weight of what he's actually doing. He spends his nights doing all this long tinkering with free Libre and open source software, which we often see abbreviated as FLUSS.
Okay, let's unpack this, because this seemingly niche programming blog is actually a goldmine of continuous learning.
Absolutely.
And there's a huge, highly practical lesson here for you, the listener. Whether you are managing a software team, studying for a degree, or just trying to optimize your own daily workflows.
The sheer discipline on display here is what immediately stands out to me. When you look at the architecture of this blog, it's not just a casual, once-in-a-while journal where someone posts when they feel inspired.
Right, it's not a diary.
No, it's a relentless, ongoing, highly structured project of documentation. Yeah, I want to look closely at the mind-boggling volume of Eng's blog archive, because the numbers here provide crucial context for the insight we're going to analyze later. In 2024, there were 732 posts.
Wow.
In 2025, another 730 posts. And by early March of 2026, which is when this specific Haskell post was published, he had already written 189 posts for the year.
That is roughly 2 posts every single day.
Every day. And the archive stretches all the way back to 2011. You look at the monthly breakdowns in the source, and it's consistently 60 or 62 posts a month after month, year after year.
That level of consistency is rare. But I'd argue that what makes this archive truly valuable isn't just the volume, it's the breadth of the material. This is a true polymath approach. We're here today to talk about part 73 of a series on Haskell programming, but if you step back and look at the project categories and the recent posts surrounding it, he isn't just looking at software. We see notes on fish keeping.
Fish keeping.
Yes, specifically, he maintains highly detailed betta spawn logs and miscellaneous fishes spawn logs.
That's amazing. And it doesn't stop with fish. He has notes on gardening. He documents his bougainvillea journeys, his discoveries of Malayan plants, and something incredibly intriguing called the gelatinous pear.
The gelatinous pear, right. And he also does intense deep dives into hardware and networking. There are posts analyzing Wi-Fi 7 MAC addresses and figuring out why a specific MediaTek Bluetooth device suddenly goes missing.
It's so varied.
Plus, he covers Elixir, Erlang, Python, Go, Rust, typesetting, meditation, dieting, home improvement, and even guitar practice. What's fascinating here is what this reveals about the author's mindset.
Right.
This isn't just a technical manual. It's a journal of relentless curiosity. Every time he encounters a complex problem, learns a new chord, or plants a new seed, he forces himself to articulate that experience in writing.
It's almost like a unified theory of learning. And what I find compelling is that this massive output is grounded in some very clear stated principles. The blog specifically lists support for the Electronic Frontier Foundation, or the EFF, the Free Software Foundation, the Tor Project, and Wikipedia.
Those affiliations are telling. They paint a vivid picture of a deeply principled internet citizen. Now, we are not endorsing these groups or taking any political sides here, but impartially looking at the text. These are organizations dedicated to privacy, open access to information, and the idea that knowledge shouldn't be locked behind walled gardens.
Exactly. We're just looking at the philosophy driving the work.
Right. And his journaling habit perfectly reflects a commitment to those foundational ideals of the early web. He's taking tools and knowledge from the open source community, but he's paying it forward by giving back an incredible amount of documented, searchable experience.
Which brings us right back to you. Think about what it would actually mean to meticulously document your own learning journey with this kind of open source philosophy. Aang isn't just writing about code. He has notes on MOOCs, massive open online courses. He reviews academic research papers. He logs his "this week I learned" takeaways.
It's comprehensive.
It shows that professional mastery isn't always about a massive sudden breakthrough. Usually it's just the compounding interest of writing down small, hard-won observations every single day.
Precisely. And this specific post we're looking at, part 73 of his Haskell notes, is a perfect, isolated example of one of those small, compounding observations. It's a micro-insight that only reveals itself because of the documentation process.
That exact philosophy of writing to clear the mental fog is what leads us to his actual technical challenge for the day. He's dealing with something every programmer dreads, and frankly, something anyone who has ever built a complex spreadsheet dreads.
Nested if statements.
Nested if statements.
It is a universal logical problem. You start with one condition. If this is true, do this. But then within that first condition, you realize you need a caveat. So you add another condition, and another.
And suddenly you're trapped.
Exactly. Soon, you are buried in layers of logic, and your code is indented so far to the right of the screen that it's unreadable.
I remember trying to untangle a block of nested ifs a few years ago that went, I kid you not, 7 layers deep.
Oh, that's brutal.
You end up spending way more time just managing the curly braces and the indentation than you do actually solving the business logic problem. It feels like you're playing a terrible game of Jenga.
That is exactly what we call technical debt. Think of nested ifs like an expanding bureaucracy. It starts with one simple rule, but soon you have clauses within clauses. Just trying to trace the execution path to figure out why a specific output happened requires you to hold 5 or 6 different logical states in your head simultaneously.
The journey of discovery Aang takes to bypass this bureaucracy is highly relatable. Remember, this is part 73 of his Haskell notes. In part 71, he was exploring something called the guard expression approach.
Right.
Then, in part 72, he looked at a different tool, the MultiWayIf extension. He was actively experimenting, trying to find the cleanest, most readable way to write this specific block of code. And here's the core takeaway. Simply the act of writing those 2 previous posts helped him arrive at an aha moment for part 73.
That is the power of documentation in real time. By forcing himself to explain the previous 2 methods in writing, he externalized his working memory. The mental fog cleared, and a third, significantly better option presented itself.
And that breakthrough was a new, simpler approach, using a helper function combined with guards. So how does Aang actually bypass that expanding bureaucracy of the nested if here?
Based strictly on Aang's text, he explains that this method works by leveraging the sequential early exit nature of guards. In Haskell syntax, these guards are represented by the pipe symbol, that vertical line on your keyboard.
Wait, so if I'm understanding this guard symbol right, is it just reading the code like a top-down checklist?
Exactly like a checklist. The text specifically points out that it leverages an early exit nature. The program looks at the first guard condition. If it is met, it executes the code and completely exits the function.
It just bails out right there.
Right. It doesn't even bother looking at the rest of the list.
Yeah.
If the first condition isn't met, it simply moves to the second, and so on, straight down the line.
That immediately makes sense. It's like having a very efficient bouncer at the door with a VIP list. Is your name on the top of the list? Great, you're in. We are done here. We don't need to read the rest of the names. Next person.
That's a perfect way to visualize it. It prevents the computer and, more importantly, the programmer who has to read the code 6 months later from having to descend into those nested layers we talked about. You evaluate one thing at a time at the top level, and you get out as soon as you find a match.
Here's where it gets really interesting. Aang points out something to help readers who might still be struggling to understand the underlying generic pattern of this code. He suggests rewriting it with only one guard condition as an exercise.
Yes.
That final fallback condition is called otherwise. And he drops this beautifully simple fact. In Haskell, the condition otherwise is quite literally just an alias for true.
It is a highly elegant piece of language design, especially for a purely functional language like Haskell, where every function has to return a value. By using the word otherwise, the code reads much more like natural human language.
It really does.
It essentially means if none of the specific conditions above have been met, then this final condition is automatically evaluated as true, so just execute this final block.
It's the ultimate catch-all. No matter what happened above, if we get all the way down the checklist to otherwise, the answer is yes, proceed with the default action.
If we connect this to the bigger picture, this is crucial for writing clean, sustainable systems. Software isn't just written for machines to execute. It's written for other humans or your future self to read and maintain.
Absolutely.
Eng's strategy of rewriting the code with only one guard condition is a masterclass in breaking a complex system down to its most basic, undeniable truth. By demonstrating that otherwise simply equals true, he demystifies the syntax and shows you the raw mechanics of how the language evaluates logic.
It highlights how a small syntactical trick can totally change your relationship with the problem you are solving, which perfectly sets up the paradigm shift Ang talks about at the very end of his post. He does a final recap comparing the original if-then-else block to his new guard approach.
And he focuses heavily on the physical, structural layout of the code itself.
Yes, this is the crucial detail of the entire deep dive. He explicitly points out that in an if-then-else block, the condition check happens after the equals binding. It sits on the right side of the equal sign. But with guards, the condition check happens before the equals binding. It sits on the left side.
This raises an important question. How does the physical layout of information, the left-to-right parsing of logic, fundamentally change how our brains process decisions?
It's a huge shift in perspective.
It really is. When the condition is on the right, after the equal sign, your brain has to read the assignment first, load it into your working memory, and then figure out if it actually applies. It's completely backward.
It's the difference between saying, you are hired if you pass this final test versus if you pass this final test, you are hired.
Exactly. Let's look at this outside of programming. Think about reading a complex legal contract.
Okay.
If a clause says the tenant is liable for a penalty of $5,000 if they violate the noise ordinance after 10 p.m., your brain immediately spikes with anxiety at the $5,000 penalty.
Right, because you've just read $5,000.
Yes, you load that heavy outcome into your working memory. Then you read the condition, and you have to retroactively apply it to the penalty you're already holding in your head to figure out if you're actually in trouble.
Right, you're stressed and burning cognitive energy before you even know if the rule applies to you.
Precisely. But if the contract is written with a condition on the left, like a Haskell guard, if the tenant violates the noise ordinance after 10 p.m., they are liable for a $5,000 penalty. The prerequisite is established first.
That changes everything.
If you don't play loud music, your brain evaluates that first condition as false, and it stops processing the rest of the sentence. You don't even need to hold the penalty in your working memory. The cognitive friction drops to almost zero.
That is brilliant. You can apply that to anything. Think about reading a medical diagnosis or even just looking at a presentation at work. If a manager buries the context, why we are here, on the final slide, the audience is confused and trying to reverse engineer the logic the entire time.
Exactly.
If you put the condition on the very first slide, everything that follows has a clear path.
In code, this left versus right shift might seem like a minor formatting detail to a beginner. But when you are dealing with massive systems, placing the prerequisite before the outcome drastically reduces the mental load required to understand the architecture. You are no longer holding suspended outcomes in your head while you search for the conditions that trigger them.
It is such a profound realization hidden inside part 73 of a Haskell programming log. So, what does this all mean? We started by looking at an old software plumber tinkering in the night.
A true polymath.
Truly. And we've unpacked the elegance of early exit guards, how they act like a checklist to stop you from spiraling into the expanding bureaucracy of nested logic. We've seen how a simple alias like otherwise for true makes highly academic systems readable. And we've explored that crucial left versus right shift in logic evaluation, proving that where you put the condition matters just as much as what the condition is because it dictates how much cognitive friction you are forcing on the reader. But most importantly, we've seen the sheer power of documenting your daily tinkerings.
We have. We've just spent our time analyzing one tiny realization, again, part 73 of just one topic, from a person who has diligently logged thousands of these micro insights since 2011, covering everything from strict functional programming to betta fish to bougainvillea journeys.
It's incredible.
It speaks to the core of why open source knowledge sharing is so vital. If a daily habit of simply writing down what you learn can build such a massive, valuable archive of knowledge, an archive that helps clear your own mental fog while simultaneously helping others, what insights are you letting slip away unrecorded today?
That is a question to sit with. Grab a notebook, open a text document, and start your own archive today. You don't have to write 2 posts a day, but just write something down. Thank you so much for joining us on this deep dive. Keep asking questions, keep documenting your journey, and above all, stay curious. We'll catch you next time.